Hello students, good evening. I hope you understood what is a zener. You have any questions to ask? Quickly. Now try. Now answer this question very carefully. Aram se. See, Aram se, I am training you, teaching you, coaching you. Okay, you have to be alert and you have to be brave and bold. Then only you can absorb the knowledge. Right? Okay. So you see. What is this? Come on, tell me first. What is this?
This is a voltage source.
Another student. I want some word. No. Something else you have to say.
It is a cell, sir.
No.
Potential, having potential.
No. Come on. See, if you understand this.
DC source.
Pardon?
Constant DC source.
Constant DC source you are telling, somebody is telling voltage source. What you should have told is constant voltage source. Constant voltage source. That means, what is the meaning of this? Constant voltage source. Okay, what is the meaning of this? The meaning of this is, now, if you see the current output, that is the current that is going to come out of this, if you connect a load resistance, R, okay, so the current that is going to come out of this, right, and or you say the voltage across. See, if I put the point here as A and B, I write it as VAB. So VAB versus current. And what is current here? Current I will be equal to V by R. Okay? So how will be the characteristic of voltage versus current? How will be the characteristic? Arey yaar, you are going to solve very, very difficult sums. You are going to solve using diodes, transistors, zeners, photodiodes, so many other things, and electrical circuits. These questions you should quickly answer. What will be the characteristic of constant voltage source? That is voltage VAB versus current.
It will be a straight line.
Yes, it will be a straight line because irrespective of the current, the voltage across will be constant. That is why it is called constant voltage source. That is irrespective of the current. See, current will change if RL changes. Correct? If RL increases, current decreases. If RL decreases, current will increase. But one thing is sure, RL must not be equal to 0. Okay? That is not permitted.
Straight line with that is a straight line passing through origin. Inclined to x-axis at a certain angle.
Right? Yeah, what are you talking? What is this you are telling? What are you telling, Abhinav?
So you are drawing V versus I graph, sir.
You only don't know it is horizontal line, straight line.
Then the slope of that graph should give resistance, sir. If you are keeping resistance constant, only then you will get that. For Ohm's law, how we use that graph, sir? We should draw the graph like that, I'm saying, sir. V versus I, sir.
Can any student answer his doubt? I am also stunned when he asked this question. Can any student answer his doubt? Come on, see, this is how everybody will get knowledge. Some from strange question like this. Even I was shocked to, Come on, anybody can answer this question?
He is talking about a situation in which how voltage current will vary with change in voltage with a particular resistance.
That is, you have got this graph V versus I or I versus V when you are considering this situation. You are considering current I and voltage I. Okay, and if this component is ohmic, then you are going to get this current. We are not doing this, man. We are measuring the voltage across a voltage source versus the current it is feeding. See, if you simply read something, you will do like this. Always voltage versus time graph will not be like that. I hope you understood, Abhinav.
Yes.
So this is voltage source versus the current. Clear? Okay, fine. Anyways, good. If you see, this boy is a very brave boy. He asks questions, strange questions, but okay. But try to avoid. You have to understand things very correctly. Right. Now, supposing I have a voltage source like this. Supposing I have a voltage source like this. This is internal resistance R. Same, everything same. Sorry. Right? This is R, same R. Wait. Then how will you get the graph? That is again, this is A, this is B. How will you get the graph VAB versus current? How will you get this graph?
Same.
Okay, Adil is telling it should be same. Anybody else? See students, here you see if the current is now varying, there is a drop here, no? There is a drop here, no? Right? So you so ideal voltage source or constant voltage source, you will get graph like this. But here you are going to get a graph like this. Understood? Voltage versus current graph will be this. I hope you understood, because some voltage will be dropped. So you see, this is constant voltage source. This is also constant voltage source, but with an internal resistance, you are going to get this graph. Got it? Now you see here. If I say I am going to draw current only up to I1, and now you see, for all practical purpose, this much drop is considered as what? As a negligible. Then, as long as you are limiting the current, load current less than this, for all practical purpose, you can consider this arrangement. See, internal resistance means it will be internal. You are not putting a resistor. For all practical purpose, you can consider this to be what? A constant voltage source. I suppose you understood?
Yes, sir.
Good.
Yes.
Now, next question. If you have understood this, you will answer the next question correctly. Right. Now, yesterday we had a situation. What is the situation? We had V in and we had R1 and say this is RL. Now, if I say the voltage across RL, this is V1, right? With varying RL. If RL varies, how will V0 vary? So, V0 is what here? V0 is what? V0 will simply be equal to what? V in divided by R1 plus RL into R1. Okay? So therefore, accordingly, if you see this graph, so you are going to get here what? V in divided by 1 plus sorry. We are going to get it as V in divided by 1 plus R1 by RL. Hello, are you with me? I have just taken RL common and I have written this.
Yes, sir.
Yes, sir. Now you see, if here you see R1 by RL is very, very small, then for all practical purpose, V0 will be equal to V. Clear?
Yes, sir.
Otherwise, you can figure out if RL varies, how will V0 vary? So RL varies, how will V0? You can understand. So here you see, if you see only this part, this is not going to give you constant voltage at this point. It depends upon this load RL. Okay, this is one issue. Now, I will give you another issue. So here you see there was another issue that we dealt yesterday. Right? What was that? We had situation like this. This is RS and say this is some R1, and to this we are connecting the load R1. Okay, and if you vary this. So again you can see, now here what will be the output voltage here? The voltage across RL. What will be the voltage across RL? Quickly, you have done a lot of electrical circuits work. You remember using superposition, Thevenin and all those things?
Yes.
So you see the circuit from here. So if you see the circuit from here, that is, you should now consider the open circuit voltage here. What will be the open circuit voltage here? Open circuit voltage here. Yes, Vin divided by Rs plus R1 into R1. This is the open circuit voltage. Then the next thing is you will short circuit this and measure the impedance seeing from here. Then it will be R1 parallel Rs, isn't it? R1 parallel Rs. That is short circuit current. This one, that will be what? R1 parallel Rs. So the Thevenin equivalent of this will be what? The Thevenin equivalent of this will be that this voltage. What will be this voltage source? This will be Vin into R1 divided by Rs plus R1. We have solved this problem, remember, in our electrical circuits. And in series with R1 parallel Rs. Okay. Then you are going to connect what here? The resistance R. Okay. So now, if you vary this, clearly we can see that the voltage across this will depend upon the value of RL, and it will vary as RL varies, and there will be a great variation in the output. Clear? Hello?
Yes.
Now, instead of this, if you replace this with a Zener, okay, right? Then what happens here? See what happens here. This Zener will ensure that this voltage across this terminal will be constant. Yesterday you have seen the Zener graph. Okay, the Zener graph will be like this. So as the current here, see the output current here. If the output current here, if the load resistance varies here, then the current through the Zener will vary between these 2 points. But the voltage across the Zener will not vary so much. So for all practical purposes, you can consider this output voltage to be constant. Okay. In other words, with the Zener, okay. See here, if you consider this circuit, you are going to get the voltage V0 versus RL graph. If you see, voltage V0 versus RL graph would be what? Would be like this. If RL, see, sorry, it was done. What it is? This is the voltage V0 versus RL. This graph for this circuit. Hello. Okay. You cannot say RL is equal to 0. So start the graph from here. Okay. Start the graph from here. And then the graph for this will be what? It will be like this. For this, because see, you should not say RL is equal to 0. For some value of RL, okay, small value of RL, the output will be less. As RL keeps on increasing, this value keeps on increasing. Voltage V0 goes on increasing. Right? Yes, please.
So then graph are drawing for which case?
This case, man. This case.
Yes, correct.
Okay. It will not be so like this, it will be slightly different, but you should have an andaz that as this one varies, this is going to change. For this circuit, that is for a limited value of RL, what will be V0 versus RL? What will be V0 versus RL? See, if RL is, again here, RL you cannot take it as 0, you will take RL value between these 2 values. So draw the graph between these 2 values. So if RL is less, so you will get a graph which is almost a straight line. Almost a straight line. Correct? For this Zener. So that is why Zener is called as a voltage regulator. I think I made myself clear. If you have any questions, you ask now quickly. Fast. Okay, if you have no questions, then solve this problem first. See, you must start abstracting like this. You should be brave and bold. Your exams are announced. Come on, now don't be afraid. You have done good job. You put your knowledge in. Okay, and in my class, you answer. You test your knowledge. If you make mistake, I will correct you. Come on, do it. Shall I have this? Okay, solve the problem. I think all of you can read the problem.
Yes, sir.
Solve it. See, you will be wonderful engineers, wonderful professionals. Well, okay. So draw the circuit here. Simple. For this. So this is 9 volts, and then they have told the VZ is this in series. So they have told here series resistance, then a Zener is connected here, and then a load RL. So here RL is fixed, and RL is equal to what? 1000 ohms. And here VZ is there, value is how much? VZ is 6 volts. Okay, and RS they have told is, sorry, RL is 1000, RS is 100 ohms. Okay. What is the power dissipated? Calculate the value of the current through the series resistor series. So they are asking you this current. This current here IS, this current here IZ, and this current here IR. Okay, quickly calculate these currents. So this is 9 volts, 6 volts is across this, so this you are taking common, 6 volts is across this, 3 volts drop is here. So IS will be what? IS will be 3 volts divided by 100 volts. Okay, so that is 30 milliamperes. Right? Then what have they asked here? Calculate the current through the series resistor, the Zener current. What is the current through the Zener? Okay. The current through to calculate current through the Zener, now 30 milliamperes is there. First you calculate what is the current through R. Okay, so what will be the current through R? Okay, I going through R. This will be what? 6 volts divided by 1000.
Yes.
Right? Good. One student is active. 6 milliamperes. Then what will be the current through the Zener? This minus this. 30 minus 6. That will be 24 milliamperes. Right. I hope you understood all these calculations. Anybody is having doubt, you ask. You learn. Be brave. Learn. Aram se learn. Okay. Then the current through Zener diode loads. What is the power being dissipated in Zener? What is the power dissipated in Zener?
V for
Correct. That's it. VZ into IZ. So that is 6 volts into 24 milliamperes. Right? But be careful to write 24 milliamperes like this. So 6 volts are 24, 6 2s are 12, plus 2 14, 144 into 10 to the power of minus 3 or 144 dB watts. Okay?
yes.
Okay, fine.
One more, sir.
Please.
So that power is dissipated in the form of heat only, no? Here also.
Yes, sir. Yes, sir. Yes, sir.
Yes, sir.
So 100 ohms. So this is got it as 3 volts. This is got it as 3 volts. I think we got all the answers right here. 3 volts, 3 volts. We got this as what? 30 milliamperes. They are written in amperes. And this we got it as 6 milliamperes. This we got it as current to 0 as 24 milliamperes. Correct? We got 24 milliamperes. And this is 144 millivolts. Yeah. Shall we move on, students?
Yes, sir. Yes, sir.
See, we have got to cover still different diodes and then transistors. Transistors is a big chapter, and then we have to do problems on that, right? And then amplifiers, oscillators using transistor, Okay, the theory is quite involved. It takes some time, and then some numericals on it. So it's a long way to go, right? And then communication chapter. Okay. A Zener diode is specified to have breadboard at 9.1. What is the maximum for this with a maximum power dissipation of 364 kilo? What is the maximum current that the diode can handle? That's quite simple, right? So 364. So this is quite simple. 364. Don't forget to do this on milliwatts divided by 9.1.
Yes, sir.
Yeah, good. Somebody is talking. So I think you can do this, right? So this should be some 4 times this. 40 minutes. Yes, 40 minutes. Thanks. Yeah. Okay, shall we proceed?
Yes, sir.
There. Now I will be teaching you a new theory, photodiode. Photodiode. Photo matlab light diode. Okay. Now here I think you would have know this photodiode. That is, you see it is like this. I will draw something like this, and then you can understand this. So here you see I will have a voltage source. I will have a voltage source in. Okay. Now I will connect. Assume that I am going to connect. Now you see I am using. Say okay. Now I will start with the diode. I will start with the diode only. I connect a diode like this, and I will connect a load resistance here. And I want to measure the output voltage. I want to measure the output voltage. Okay. Now can you tell me what is the output voltage of the diode? What is the voltage here? V naught equal to and also the current IL. IL equal to what and V naught equal to R. Come on, aram se think and tell.
Ideal direction.
Ideal rate. IL is 0. Why it is 0?
It is reverse biased.
Excellent. And then what is V naught?
That should also be reversed.
Why? Why?
Because whole potential is supplied to that diode.
Why? How do you say it?
So because if you consider the graph of that diode cell, initially sir before breakdown it will for a large potential also it will have very less current. So all the potential will have, and it will have a high R. Okay. You are analyzing it in a different manner. Anybody else can tell me why V naught is 0? What is V naught, man? V naught is what? IL into RL. IL is 0, therefore V naught is 0. Simple. Yes.
Simple. Don't complicate it. Simple. So this is the thing. This is the graph. Now try to understand. Now let's try to understand. What is there? What is this one? It has got P and N. And then yes, 2 electrodes are there. And what is this? This is depletion. In depletion layer you have got what? The ions, immovable ions. And why they are immovable ions? Because they have trapped the charges and they have become immovable ions. Okay. Yes. Now imagine if you provide some energy to this, energy such that the electron which is locked here, okay, by the hole that has come here is released. Right? If the electron is released here by some energy, what will happen? This electron which is released here, hello, are you with me? You know that there is an electric field like this because it is reverse biased. If at all this in this depletion layer a hole has combined with the electron and now it is released, it comes out of the bond. Then a free electron is generated here and then the electric field is in this direction. You know why the electric field is in this direction, correct? Hello? So what happens? Because of this electric field, this electron which was released here, and also you can say a hole that was released here. The hole will move in this direction, electron will move in this direction. Agree? That means there will be, in addition to the reverse bias current, there will be additional current. That means the reverse bias current will increase. Correct?
Yes, sir.
Correct? No? Now I told you some energy is given to the electrons. Okay. Now one of the ways is that, see, when you see a diode, diode will be a small thing like this. They will make a glass window. These photodiodes will have a glass window. See, usually the diodes will be like this. If you see diode, it will be like this and it will be very black in color. Okay? But if you see a photodiode, there will be a window here. Means a transparent layer will be here. So transparent layer there, light can enter. The photons can enter. Okay? So photons can enter. So if photon enters here, and if this photon is captured by these ions, then it will release the carrier charges. And those carrier charges will enhance the reverse bias current. Did you understand that?
Yes, sir.
Okay, that is one thing. In your textbook, that is what they have given, that is what I have explained. Now, interestingly, in photodiode, they are not using PN junction, but they are going to use PIN junction. P is P-type, N is N-type, I is intrinsic semiconductor. You can see here, that is an intrinsic semiconductor is sandwiched between a P and an N. Hello, are you with me?
Yes, sir.
Intrinsic semiconductor means what? It will contain holes and electrons, thermally generated holes and electrons. Correct now?
Yes, sir.
It will get thermal. But what happens here? There will be depletion layer here. Understood? And therefore, whatever thermally generated holes and electrons are generated here, they will also be locked inside. Or few few thermally generated holes and electrons will be there, and maybe yes, they will contribute to the reverse bias current. If you have forward bias, they will contribute, but small reverse. So there was small reverse bias. Now slightly more reverse bias current will flow. Correct?
Yes.
Okay. Now supposing light energy falls on this intrinsic semiconductor, then more number of these holes and electrons will be generated. The intensity of light is more, then more number of free electrons and holes will be generated. So the reverse bias current will increase. Correct? Hello?
Yes, sir.
Now, when no light is there, this current that is flowing through this, that is, you should complete the circuit. See, now here instead of this diode, I will just write it as a pin diode. Okay, if in your textbook they are not given this pin diode, don't write pin diode. This is for your knowledge I am giving you. But in your textbook they have just a simple diode. Then you just write a simple diode. But the thing is, the symbol. See, the symbol for this pin, this is like this. The symbol for a photodiode will simply be like this. Understood? That is, light can enter this. There is a symbol for a photodiode. So in that case, what happens? See, a small reverse bias current will be flowing through this. Agreed? A small reverse bias current will be flowing through this, and therefore, the small reverse bias current will be flowing. You can see here, this graph. All of you can see this. So a small reverse bias current will be flowing. So here you see the reverse bias voltage is minus 5 volts. Assume. So at minus 5 volts, you will have this much current. So this current will be very, very small current in 5 parameters. Correct? Now, if the intensity of light slightly increases, they are told here, 1000 lux. The light is measured, the intensity of the light, lux, 1000 light. Then what happens? The reverse bias current will increase by this much. And still, if you increase the intensity, the reverse bias current will keep on increasing. Can you see this? Now, this is called dark current. Dark current means that is no light is falling, but still you will have small current because of the reverse bias voltage. That is what is called as the dark current. Okay. Now, if you take the reverse current versus luminance or the light falling on this, then you will get a curve like this. Okay. This is the characteristic of the reverse bias current versus the light. So you can see that as the intensity of the light increases, the current will also increase. Got it? Now you see, you can use this to do many things. Like for example, you can switch. You can switch. That is, you see, there is something called as there is a see. Assume that you know I will be teaching you something. There is a device. There is a device. Okay. And what we do to this device, we will give some high voltage. High voltage will 10 volts, 20 volts, things like that. We will give this voltage to this through some resistor IC, okay, and ground. Okay, we will give this. Now, this current flowing here will initially be equal to 0. Will initially be equal to 0. Okay, why it will be equal to 0? You see here, I have connected the photodiode. I have connected a photodiode to this. Photodiode to this. I have connected a photodiode to this. Okay, so I will be connecting the photodiode to this. So here you see this is anode, this is cathode. I have connected this like this. Okay, so this I will connect as cathode. So this diode is reverse biased. I suppose you can see this, right? This is photodiode. Okay. Now this device, what it do? The current is 0. The current is 0 if no light falling on this. No light on photodiode. No light is falling on photodiode. This current is 0. Tell me.
That VCC, sir, that potential is there, that is not affected by diode.
That is not
affected by diode.
No, see, it is not affected by diode. It is just a voltage source. Listen, yeah, I have not told what is there inside this. See, this is just a voltage source like this. See, now you should understand, you should go with me, you should not go ahead of me. Okay, then you see I will get distracted, you will get distracted. What did I tell you? Consider some device. I didn't tell you what is the device. So that I have put a resistor and I have given some supply voltage to this. And no current is flowing in this. If no light is falling on the diode. Got it?
Yes, sir.
Just follow this. No light is falling, no current. Now, this current I will become equal to I1. And I1 is greater than 0. If light falls on the diode. Got it?
Yes.
Okay, so that means now this current will instantly rise if light falls on this diode. If no light, this current is 0. Got it? Now this I have written as RC. So this is a load. Supposing say you have an alarm. Okay. Supposing say you have some alarm. So the alarm, now don't ask me what is that kind of. So this alarm is a device. If current flows through this alarm, then you will get sound. If no current flows through the alarm, no sound. Got it?
Yes, sir.
So that means now here I is equal to 0 if no light is falling on this. The moment light falls on this alarm becomes on. Okay, this alarm becomes on, and then the hooter becomes on. Right? For example, in your home, you have kept your tijori, right? And you have secured it. You have connected this alarm. I am just showing you some schematic. Alarms are nicely designed and all. That is, I am just showing you the principle of this. So, supposing a thief enters, and then he switches on the light in where the tijori is kept. So the light falls on this layer, the hooter becomes on. So then it is to be like that. So there are many devices like this. So you can use a photodiode like this, and in say many of the toilets. Okay, so you keep your hand down then water will come. Take your hand off, water will come. So they are using, they might have used a photodiode there. We should do this. I hope I made this clear.
Yes, sir.
Yes, sir.
Good. Okay. Next. Ask, you had some question?
That device.
That device you forget, man. I will teach you. Transistor. Let's say transistor. When I teach you transistor, you will learn. Okay? Don't see now. You see when I say device, you have to accept it, because I have reasons. See, your syllabus I have got to complete, and you know now time is very less for you and me. Okay? I know all those things. That doesn't mean I should start showing my panditya and go on teaching whatever I know. No. I have to ensure that your syllabus is completed. You get the right knowledge. You get the right skills, and you are quite capable of writing the examinations. Okay? Those things which are not in the purview of syllabus, I will not explain. Time is less. I am very sorry. As a teacher, I should tell you everything, whatever I know. But, well, we are all into a zone where, fine. LED. I think all of you know what is a LED. You have seen a LED, right? So, in this LED, I have written in Sanshipta, a LED light emitting diode is a semiconductor device that emits light when current flows through it. Electrons in the semiconductor recombine with the holes, releasing energy in the form of photons. The color of the light corresponding to the energy of the photons is determined by the energy required for the electrons to cross the band. White light is obtained using multiple semiconductor layers. So that's it. So here you see, see it's all the semiconductor device, P and N structures. Okay, and here you see this photodiode is exactly the ulta of this LED is ulta of photodiode. Okay, so an LED, the symbol for LED will be like this because it is going to emit light. We'll show it like this. Okay, so here the thing is now we shall look at the band structure. So there are conduction band and there is valence band. So a conduction band electron has got what? High energy. High energy. Okay, and when this conduction band electron falls into the valence band and it traps, that means this electron has now lost energy. Hello, are you with me? Lost energy. That lost energy lost by this electron will appear as light. Will appear as light. Okay, and that is the light that comes out, and therefore this as the current is flowing through the diode, there is a window. See, this diode is made such there is a window and light can come out of it. And as the current is when the diode is forward biased, when the diode is forward biased, just like a normal diode it works, but it has got a window and the doping and all is in such a manner that it is going to emit light. Okay, because the electron jumping from conduction band to valence band is going to emit the radiations. Correct?
Yes, sir.
So you should know that the circuit for that will be like this. You have got a voltage source plus minus, a diode is connected, a resistor is connected. So this resistor is going to limit the current. Larger the current, brighter will be the LED, but that current cannot be infinite, right? So that is it. If you allow so much current, you will get so much brightness of the light. Ask.
Sir, why will it jump to such an extent with increasing current?
You must ask your question correctly. That is, you see, last word what you said, I could not hear. You keep your voice loudness same till you complete the answer. Once again, ask.
How will it change current?
How will it change what?
With current, sir, if increase current, it will increase.
See, now what happens? Now what happens here? The normal diode, what happens in normal diode? The majority charges will flow from P to N. Okay, minority charges will flow from N to P. Correct now? Majority. The conventional current will be from P to N. Correct? The reverse current will be from N to P. Correct? Because of the reverse current is because of the minority charges. This is what we have seen is a macro picture. As a macro picture. Now let us look at it at a micro picture. Micro picture. What is that micro picture? See, the electrons which are moving inside, they would collide with other ions, etc. So there is some sort of heat generated there. Okay, and with that heat, other electrons in the valence band are made to absorb that heat. And that heat, it will create a hole by sending the electrons to the conduction band. Got it? A hole is created, an electron. Now they make the doping and the structure there, which is not for your purview, but just understand, such that you will be able to create a lot of electrons into the conduction band momentarily. See, the electrons which go to conduction band, they will not stay there forever. You like your aunt's place. Okay, but so you will go in vacation for your aunt's place. How many days? 1 week, 2 weeks. Afterwards, again you want to come back to your parents' place. That is the law of the nature. So the stable position for all the electrons is in the bond, in the electron bond. But somehow, for some reason, the electron jumps to conduction band. It stays there momentarily and then comes back. This is the nature. So this is controlled by proper doping and structuring this one, and they make it to emit light. And that is light emitting diode. See, at this level you understand only so much. When you come to engineering, you will learn a lot more about this. Okay? Now, I think all of you can see this picture nicely. It's still bigger. Solar cell. Okay. Now this is the talk of the talk, because now energy crisis all over the world. Okay. The symbol for solar cell is this. That means, you see, light is falling and a cell is created. Solar energy is converted into light energy. So you see, solar cell, photovoltaic cell is an electronic device that converts the energy of light directly into electricity. Electricity means electrical energy. Generation of charge, generation of electrical power is electricity. By photovoltaic effect, which is physical and chemical phenomenon. It is physical and chemical phenomena. But there will be chemical phenomena, but it is reversible. That is, when light is falling, there is a chemical reaction. But when you take energy from that chemical reaction is ulta. That is, the reactants are given back. Okay. It is a form of photovoltaic cell defined by a device whose electrical characteristics such as current, voltage, resistance vary when exposed to light. Individual solar cell devices are often the building blocks for photovoltaic models, colloquially called as solar panels. The common single junction solar cell can produce maximum output circuit voltages 0.5 to this. Okay. Now I think regarding the construction and all, even for LED and all, very nice diagrams and explanation is given in your NCERT. And I am sure if you read that, you will all understand. What is necessary to understand, I am teaching today. Okay. Now look at this diagram. So what do you see in this diagram? You can see this purple color zone. What is this purple color zone? The depletion rate. And then you have got N-type here and P-type here. And now you can very clearly see. See the N-type, you see the dark dots, they are the electrons. And these are all the donor ions. These are the acceptor ions. So the electron is trapped by the holes in the depletion. I think this diagram is clear. That is what there will be normally, that is what will happen. Now you can see that when light falls on this, you can see the yellow streak here, light falls on this, trapped electron is now released and is now released. Okay, and as you know, there is electric field, so when the trapped charge is released, the electron will go back to the N zone and the hole will come to the P zone. Got it? Hello?
Yes, sir.
Then, see, normally a PN junction, you see here, a PN junction, that is a normal diode, it will have two non-rectifying electrons. I think now you understood what is non-rectifying electrodes. Rectifying electrodes means, rectifying means it will allow current in only one direction. See, here, this is a metal. Okay, so the current can go here and come out. Okay, understand? So you must not say, oh, metal has got free electrons and there is holes here, so this will form a PN junction. It will not form a PN junction. Okay, that is why this is called as non-rectifying electrodes. So in this case, what is done here is you have got a P and you have got a N, right? And then you have got a layer of metal. I think this is all given very nicely in your textbook. Okay, and then you have electrons. So here, whatever holes are created here and electrons are created here, the electrons will come and start, because this is a metal, no? Hello, this metal will start getting charged. So this will get negatively charged and this plate will get positively charged. Hello, are you with me?
Yes, sir.
Now try to understand this. So when light falls on this, so the holes come this side and the electrons will go this side. I hope this diagram is clear. And this electron which comes this side, now try to understand, there is also an electric field, internal electric field there. So due to this internal electric field, what happens? This hole will be pushed here and the electron will be pushed here. Now this junction is such that the electrons which come here, they will charge this metal plate. They will charge this metal plate. Similarly, this will charge this metal plate, and whatever charges are put there, that charges will be retained. Hello, are you with me?
Yes, sir.
They will retain.
Yes.
So now this is positively charged plate and this is negatively charged. Now, if you connect the external load, say such as a bulb or something like this, to this, then the electric current will flow. The electric current will flow through this. So this is just like a cell. This is just like a cell. If you connect a bulb to this, the bulb will flow. So whatever solar energy is given, that will be, this energy is used. See here, this solar energy is used to create these holes and error. Create means what? They were trapped and they will be released. And then these collectors will collect this hole and these plates are charged. See, in a chemical cell, what happens? You have got the electrodes, the copper and the zinc electrodes. So chemical reaction will take place and both these electrodes will be charged. The moment you connect the external circuit, the current will start flowing. I suppose you remember that. Here, similarly, here you have got this system. Now, for your syllabus, only this much is there. I have given you a clear picture about it. Some more details are there in your textbook. Read it. If you have any questions, you ask me tomorrow. If you have not understood some point in the textbook, I will explain. Right? Please.
So here, sir, actually the light should fall on the junction part, no?
Junction part.
It falls on the top layer.
Top layer, no man. There is a window. ये ऐसा बनाते हैं. ये assume that this is a photo diagram. Okay. Hello. This is the solar. Okay. Assume that this is solar. So this light, so that depletion layer is there. No, the light is made to fall on that. Right? And this is precisely what happens. See, this schematic diagram is clear to you. Why are you worried? Schematic diagram is clear. It is falling on the, see, this zone. This zone is what? This zone is the depletion layer. Light is falling on this. Got it? Got it?
So in the solar panels, the blue region, what we see is the junction.
See now, listen here. See, listen student. See, there is something called as science. Then there is something called as a technology. And then there is something called as engineering. You engineer the technology. But what you are learning now is only the principles, the science behind it. Okay? Now don't bother too much about, engineering part. Okay? Because there is no time for me to explain and there is no time for you to learn. Please excuse me. Okay? See, when you go to higher classes, you will have to learn this, whether you want or you don't want. Right? And you will learn a lot more details about this. See, at this stage, it is very important that all of you know what is a solar cell, what is solar power, what is solar energy, what are these devices, because you see, you are putting science to best use. Okay, and see the magic. We create a P type of semiconductor, N type of semiconductor, we form a junction, and see, so many things we are doing. Now, this will, see, the idea of education is, this will enthuse you to learn more about it. Understand? That is the idea of this PU syllabus. PU syllabus will will motivate you to further your education. It will make you hungry. It will enthuse you. This knowledge I want. This knowledge I want. Oh, I want to learn more. I want to go to good colleges. That is the reason why this are. So ultimately, you would have got enough knowledge, and then you can really contribute to the world. So at PU level, learn the principles. Don't try to learn any engineering. Got it? Bye. Now, in Sankshipt, I have put all these things just for you. I think all of you can read this. Okay, in Sankshipt I have told you all these things. Right. In SERT also they are giving elaborately more, you read that. I am just giving you this additional knowledge and the knowledge to support you to understand the NCERT. I am sure, because that is an exciting topic, LED, this and all, you will read it and you will understand. Where? Okay. So now this is these are all the outcomes of PN junction. Now students, again, you have got a P type of material, N type of material, and then of course electrode surface. Then you have got what is called as depletion. Correct? Hello? See here, the concept here is, this region is depletion layer. Why is it called depletion layer? I have already told you. Depletion region. Why is it called depletion region? Faster. Tell me fast, man. Why is it called depletion region?
It contains immobile surface.
It contains immobile. What did he say?
Ions.
Ions. And what is important is that there are no free charge carriers. Okay? But this one, this P contains mobile charge carriers, so this you can consider it as a conductor.
Okay.
And here also there are charge carriers. This also you can consider as a conductor. And this one, you see here very carefully. See, for an ion here, there is a positive ion and there is a negative ion, right? And they are separated by a small distance. Can you see here? Hello?
Yes.
They are separated by a small distance. So there are two charges of equal magnitude separated by a finite distance. Correct? So when you have a negative charge and when you have a positive charge separated by a finite distance, then what does this constitute?
Dipole.
Excellent. It constitutes a dipole. Correct? So I will represent a dipole like this. Am I right?
Okay.
Negative to positive. Correct? So in this depletion region, you have got what? Dipoles. You have got dipoles. Correct?
Yes.
Have I shown it correctly here? There are positive ions and there are negative ions. I am showing the dipoles like this. Am I right? Say here I have shown the dipole symbol as negative to positive. But here I am showing it like this. Which is correct? Which is correct, man?
Outside of
Should be positive to
the
Pardon?
positive to negative.
You confirm. See,
Positive to negative.
positive to negative, no?
sir, outside.
Symbol for dipole. Huh? Symbol for dipole. Symbol for dipole. If I write dipole is like this.
Negative to positive.
Negative to positive.
Negative to positive. Correct?
Yes.
Huh?
Yes, sir.
Huh. Negative to positive. But what am I showing here? Positive to negative. Am I right?
No, sir.
I am wrong.
You
Tell me wrong.
should go from negative to positive.
I should show from negative to positive. That's what you have to be alert. Right, negative to positive. So here you see there are dipoles aligned in this direction. Do you appreciate that? Arey yaar, do you appreciate it?
Yes.
Yes, yes.
So what I want to say is
Sir, yes, sir.
there is this one, there is a conductor. This one, there is a conductor. And in between you have got dipoles. Then what is this? Two conductors separated by a dielectric. What does it constitute? It constitutes a capacitor. It constitutes a capacitor. Simple. It constitutes a capacitor. So therefore now, in a different perspective, a PN junction, okay, a diode can also be looked as a capacitor. Got it? Hello?
Yes,
Yes.
Now answer this question carefully. So you have studied capacitors. Okay? Now assume that I have got a voltage source. So if I vary this voltage, what will be the value of the capacitor? Will the capacitor also vary? If I vary the external voltage here, will the capacitor vary? Will the value of the capacitor vary?
Capacitor, sir?
Capacitor.
Yes.
No, sir.
Capacitor is independent of this voltage or this voltage or say AB. Okay? So if VAB varies, capacitor will not vary. Correct now? So C is constant.
Yes.
Again. Now you see here. Supposing I connect this to a voltage source. And I vary this voltage. If I vary this voltage, what happens? Here. Hello? If I vary the voltage, yes please,
There is some current flowing.
there is some current flow. So if I vary this voltage, what will happen? Current will flow. Okay, what else?
Sir,
What else will happen? See, that is what I am teaching you theory, man. See, all these are interconnected. You cannot, this is not your high school. Sir, you can learn, in 5th standard, 6th standard, when I was a student, you can study any chapter, first 6th chapter, then 1st chapter. चलता था. अभी ऐसे नहीं चलेगा. ये सीखने के बाद, ये सीखने के बाद, because this will all be used. They are told, I have explained this. If this voltage varies, what else will vary? Not only the current, what else will vary?
the depletion layer will.
The depletion thickness will vary.
Yes.
See, capacitor is what? Epsilon naught A by D. Correct now?
Yes.
Yes.
So here you see. Now, what is D? The thickness of the depletion. What is A? Cross section area. Right? So here if you vary the voltage, the depletion thickness will vary. So the capacitor will change. The capacitor. So if you now consider this as a capacitor, this capacitor will vary with the varying voltage. So that is why it's named varactor. Variable capacitor. Very important is you have created a capacitor whose value you can control by the external source.
Yes.
See, mechanical, see this capacitor, the plates are, the arrangement is mechanical. If you want to vary this capacitance, then you have to physically move the plates or physically insert a dielectric. But here you see, by controlling the voltage, you can vary the capacity. These are all very, very important things. You can, whatever you are seeing electronics, no? So, सभी electronics, mobile phone, car में gadget, वो gadget, सब में यही है. ऐसा छोटे छोटे बहुत सारे devices हैं. देखें? And it's all fantastic and fascinating and very cheap. Why? Because of, semiconductor technology. Right. So, you see. Huh?
Sir, that area which is that dielectric area, sir, we have a constant, like dielectric constant, sir.
See, now let's not get into those details. Let's not get into those details. Okay? See, please. I want you to just understand the principle. Now, you see, if you want to understand that, there is a math model for this. There is a math model for this. That math model contains so many terms. It is very complicated. Right? So, with that only you can understand many more things. See, whatever I could explain using, logic and so, I have explained. But if you want to go into the depth of it, then I should give you the math model of the depletion layer. The math model of the depletion layer contains many terms and very complex terms. It's not for you and me in this class. Okay? Now just understand the principle. At this stage, if you are able to appreciate and say, look, a PN junction forms a capacitor, and the value of the capacitor I can control by external voltage. Sufficient. More than sufficient. That's all. Right? Right. Okay. So this diagram is given like this, and the symbol for this is this. Okay. Now, diode laser. Okay. So laser means, you know what is a laser, right? What is laser? Light amplified by simulated emulation of radiation. Okay. Now, what happens in a laser? See, now laser I'll tell you in brief. See, now there are certain materials like ruby crystal, etc., which are called as lasing materials. Some crystals. So there you see, there is a mechanism by which you are able to take the electrons from their lower level to higher. Lower energy level to higher. That is, they are made to move from lower orbits to higher orbits. Are you getting it? So now here you see there are many atoms. There are atoms with electrons, atoms with electrons. Now there is a mechanism by which you will elevate the electrons from lower energy level to higher energy. Correct?
Yes, sir.
So there are many electrons lying in the higher energy. Okay, now listen very carefully. So the energy difference between these two is delta M. Energy difference between these two is delta M. Now these electrons at higher energy level, leave it by itself. They will come back to its original level on its own. But they will take some time to come. They will take some time. On their own they will come. Right? On their own they will come. See, for example, supposing in your school ground, you are all 100 students. So your teacher tells all of you go and stand there. Say some 20 meters from here, you all go and stand there in a line. You will go and stand there in a line. Right? You go and stand there in the line. Then after 15-20 minutes, the teacher will go away. When the PE teacher is there, he has made you to stand there, and the PE teacher took his scooter and went away. What will you do? Come on, what will you do in the school? Yeah, why only Adil is answering, man? Others don't go to school. What will you do, man? Even this small question, Prabhu, Anushri, Adil is, you don't want to answer, you don't want to pass any exam. This small question you try to answer now. There is nothing high tech about this. There is no maths, there is nothing here. In school ground, you are all at your at the outskirts of, just outside your classroom, and PE teacher tells you go and stand there at 20 minutes. You have gone and stood, and then the PE teacher after some time you will go away. It is evening, 5 o'clock. Then what will you do? Like good children, will you be standing there forever? Say, hey, teacher gaya bhai, jealous. You will start coming back to the classroom now.
Yes, sir.
You will start coming back to the classroom. Will all the 100 students come back to the classroom in time? No. From Adil will start coming, then after some time Abhinav and his friends, then somebody will come. Like that, you will all start, ultimately all of you will come at your own time. Correct now?
Yes, sir.
So each one of them will return back to this, and every time an electron is returning back to its ground state, it will emit one photon. Correct? It will emit photon. Correct now?
Yes, sir.
Very difficult to teach you students. Come on, you respond. You will come. So every time one photon will be emitted, as it is for now. Now I'll give a situation. You are 100 students standing there, right? Now your PE teacher will whistle and say, "Run!" Immediately come. Then all of you will rush back. Correct now? In all of you together will come back to the classroom. Yes or no?
Yes, sir.
Same thing happens here. By some mechanism, you have made the electrons jump from lower level to higher level, and there are many electrons populated at the higher energy level. And then you see there is some photon which is sent here. That photon energy will be equal to delta E. So this photon, when it travels like this, it will instantly stimulate all these electrons to jump to its ground state simultaneously. Understood? Simultaneously, all of them will fall. Now, that is what is the lasing principle. This chapter is not to teach you lasers, but just understand this. So, these electrons are meant to come back to its ground state altogether. So, that means now, every electron falling, they will emit one photon. But here, 100 are there, 100 of them are coming together. So, the photon that is going to come out of this, or the light energy that is going to come out of this, is 100 times that of each photon. So that is why we call it as laser, light amplification. Why light is amplified? Here you have sent only one photon. This one photon has created an energy equal to many photons. And they are jumping from one energy level to same energy. That means the frequency h nu is same. So you will get many photons emitted simultaneously having same frequency. So that is why laser lights are very sharp and very, very powerful. Got it? So this is precisely what happens in a laser diode. So in a diode also, you are pushing the electrons from valence band to conduction band. The technology is such, and then you make these electrons from conduction band come back to the valence band simultaneously. Then the light, that is the energy that is giving out, will be similar to the laser light that is giving out. That is why it is called laser diode. I have told you more than what is necessary. This much you understand. Enough. Okay? I know you will have questions. So how it will happen and all? That is what is technology and engineering. Please. Or even some more science, but that is not for your syllabus. But please understand this much. And after you finish writing all your exams now, your mains, NEET, advanced and all that, then you will have 5 to 6 months time before your college starts. So that time you can read all this for your own and you can also enjoy this. Okay, shall I proceed?